Yes, you are welcome to my YouTube channel. Today, I'll be showing you how to design a rib slab. I'll be showing you what? I'll be showing you how to design a rib slab. Yes, please, I want you to pay very close attention to this class. I've had series of people coming to my DM and saying that, engineer, please, can you show us how to design a rib slab? That what they are seeing on YouTube is not really concise enough. So today I've decided to show you how to design a rib slab. Now for this rib slab design now, I need you to pay very close attention. Now the first thing we need to do is to model the rib. Now for us to model the rib now, we will go to model, then we'll click on rib slab. When we click on rib slab, then it brings out this dialog box. Now let me show you the model that I've made. This is the model, this is the section of a rib slab that I designed, that has been constructed already. This is what we have. Now for if you look at the software, the BW signifies the rib width. The rib width. Now let's go to my section and let's look at what I have there. My rib width here is 150 millimeter. You can see where the arrows are actually starting from and where they are ending. My rib width is what? 150 millimeter. So you go into the software and you type 150 mm. You type 150 millimeter based on this. Then let's go back. My H slab is the total height of my rib slab, including the topping, which in this case is what? 325 millimeter. So we go to my software and input what? 325 millimeter. Are we together? Then my H slab is the thickness of my topping. My H slab is what? Is the thickness of my topping. And in the section I have here, my H slab is what? Is actually what? 75 millimeter. Is what? 75 millimeter. That is my H slab. Now, my S block is actually the width of my block. Some people use polystyrene, some people use clay pot, while some people leave it like that and just fill it up with concrete. But in this case, the width of my S block is what? 330 millimeter. So we come into the software and we input what? 330 millimeter. Then now let's go to the load now. Let's go to the load. Now the load, my dead load, we can select room for my dead load. My imposed load is actually residential building, so it's actually 1.5 millimeter. Then we drop it. We drop it. When we drop it now, then let's click round. Let's click round. Let's click round. I just did this model just to teach you. Now you can see that my rib slab has been modeled already. Now it is advisable for you to make your rib span in the direction of the shorter span. It makes a whole lot of sense to make it span in the direction of the shorter span. Why? Because it actually reduces the rib being involved in deflection. When you span it across the longer span, then that means that you might be needing a bigger size of reinforcement and you might need to increase the thickness of the slab more. So when you put it in the shorter span, it actually saves you a whole lot of stress in trying to make sure that the slab passes deflection. Now the next thing we need to do now is what? Is for us to now, okay, let me show you what we just modeled now in the 3D. Let me show you what we just modeled in the 3D now. So you can see, like I said, this is just to show you the how to design a rib slab, because I've actually had people coming to my DMs telling me that I should do a video on rib slab design. Now, very good. Now the next thing we need to do now is to do what? Is to draw our slab strip. Now, let me repeat something for you. For rib slab, we actually make use of finite element analysis for the design of a rib slab. We make use of what? Finite element analysis. We can also make use of finite element analysis for the design of a solid slab, but most times we actually make use of what? Analytical strip. So for the rib slab now, what we use is what? FE strip. That is what we use for a rib slab. Now you can see that this one is actually bob to bob because I have a beam at the beginning and I also have a beam at the end. So it's actually bob to bob. It's on X. So I will draw my strip, hold down my control key and draw. Okay, it says FE flow analysis, yes, because I've not run the analysis. So let's just click on OK. So let's take this also. Sorry. Let's take this also. Hold down your control key and drop it. Let's take this also. Hold down your control key and let's drop it. Now let's do in the Y direction. Let's do in the Y direction too. Now let's click on the Y. Let's hold down your control key and you drop it. Then let's take this also. Hold down your control key and you drop it. Let's take this place also. Hold down your control key and you drop it. Yes, it's actually coming out now. The next thing we need to do now after drawing our strip is to go and set our structure before running the analysis. Now, because we are actually designing a rib slab for this, so I won't be setting the columns and the beam. I won't be setting the columns and the beam. I will only go and set the rib. So let me go and set the concrete grade and the reinforcement size. Let me go and set it. Now let's go to okay, sorry about that. Let's go to settings. Let's go to settings center. Let's go to beam, design parameters. Okay, so we have the rib beams here. We have the rib beams here. Now my steel beam diameter, I want it to be a minimum of 10 and a maximum of 16. Yes, I want it to be a maximum of 16. My link diameter, I want it to be 10. I don't want 13. I just want it to be 10. Then my link spacing, most times I leave my link spacing at 200. Yes, I make the minimum to be 200. So I believe we are good to go because I'm only designing the rib. I'm not designing the columns and the beam. I just want to show you how to design the rib. Now, the next thing we need to do now is to go and set our steel grade and our reinforcement grade. So we'll go to analysis now. Let's go to building analysis. Then, okay, let's check our model first. Let's check our model if there are any errors. Let's check. So we have 0 errors. No, sorry, that's not what I intended. Okay, so let's go to edit materials now. Let's go to edit materials and let's go to the rib. So okay, this is the rib. So the concrete grade is actually, I want it to be C20. Okay, you can leave it, but my designs are actually C25. So let's pick C25. My steel grade 410, which is actually very, very okay. So click on OK. Then we can now proceed with the analysis. Now let's go to building analysis now. Although I don't want to design, okay, let me just check this. Let me check this. So let's click on building analysis. Yes, let's wait for it to finish running the analysis for the columns and the beam. Let's wait for it to finish running the analysis for the columns and the beams. Then we can now proceed with the FE floor analysis. Then from there we can now design the rib beams. Then I can now take you to some engineering decisions that you would make when the result of the ribs actually comes out. So let's wait for it to finish designing the beams and the columns. Then we can proceed to design the rib. So please, if you have not subscribed to my YouTube channel, kindly subscribe to my YouTube channel. You do not want to miss the amazing content that I'm going to be churning out. Like I said, I'll be designing a pie foundation, a beam raft foundation, and a slab raft foundation on this my YouTube channel. Please, I need you to subscribe to my YouTube channel. Okay, very good. Now, the next thing we need to do now is what? The next thing we need to do now is to now go to FE flow analysis and run the analysis, because we're actually dealing with a slab. Now, change this to 0.25. Sorry, change it to 0.25 for the slab. Let's change it. Then we can include column sections FE. Okay, let's just check this. Yeah, let's click on this. Let's wait for it to load. Like I said, I'll be dropping videos on slab raft and beam raft, and I'll also be designing a pie foundation also in this my YouTube channel. So please, I need you to stick around, and I need you to click on the subscribe button. It is very, very important, because I'll be churning out amazing content on this my YouTube channel. Now, having done the FE floor analysis, the next thing we need to do now is to do what? Is to now go and design our rib beams. Is to do what? Is to go and design our rib beams. So when you get here, you go to batch mode, then you click on check steel beam. When previous bars are insufficient, then you design, then you close. Can you see that all our ribs actually passed? Now let's now do some engineering, some interactive design with the ribs. Let's do interactive design with the ribs now. Yes, what is that? Yes, the Prota 2022 doesn't actually have this thing 12 That's why it's actually providing one Y13. But you know that we can't have one number of reinforcements in a beam. It doesn't satisfy the minimum percentage of reinforcement that should be in a beam. So what I want to do is now is that I'm going to reduce this to 10. You see, when I reduce it to 10, you can see that the ribs are failing. The rib beams are failing. So I have reduced the diameter to 10. What I can do now is to now increase the number of bars. You see that it has passed now. The same thing for the top here also is failing. So increase it to 2. That's passed. So we have this. So sorry, reduce 10 to it has passed. So 10 to it has passed. I don't know if you understand what I'm doing here. 2 it has passed. So you can see I'm reducing the diameter and I'm increasing the number of bars. I'm reducing the diameters and I'm increasing the number of bars. I'm reducing the diameter and I'm also increasing what? The number of bars. So let me show you the detailed drawing of the ribs. Let me show you the detailed drawing of the rib. Let me show you the detailed drawing of the rib. Let's wait for it to come up. Yes, let's wait for it to come up. Yes, so how many you can see? Okay, is telling us that it's 10 So this can be adjusted. This can be adjusted. Let's try and increase this to 200. That is why you need to understand how to use the software. Some people say that Prota structure is not good. Prota structure is not good. But the issue is that they do not know how to make use of the software. So let's make this 200. Let's make this 200. That's why you need to know the principles of manual calculation first. Of manual calculation before you start delving into using the software. So let's come here and let's increase this. Yes, now let me show you now. Let me show you the detailed drawing. Yes, you can see now. So we have 10 at 200. You have 2Y10 all through. We have 2Y10 all through. We have 2Y10 all through. So you can see that everything has actually passed. That is for this. So that is how everything is actually is. That is how everything is actually is. So what you do, make this 10, increase this. Can you see? Make this 2. So you can reduce this, increase this. Are we together? Reduce this. Okay, reduce this, increase it to 2. Reduce this, increase it to 2. Reduce this, increase it to 2. Can you, can you see? Increase it to 2. Reduce this, increase this to 2. Reduce this, increase this to 2. Can you see? Let's check this also. So it actually has the same details. It has what? The same details. So let's make this okay. Now, um, let me show you. Okay, there's no need. I think we can stop here. We can stop here. Please, if you have any question as regards the design of the rib, I'm coming. Let me just go to review and let's see what we have here. If you have any question as regards the design of a roof slab, you can drop your questions in the comment section. You can see that everything passed, the columns, the beams, and the rib, everything passed. Please kindly drop your question in the comment section and I will be there to actually attend to your question immediately. So we are going to be stopping the design of this rib slab here. We'll be stopping it here. If you have any question, kindly drop it. Thank you very much for your time.